Welcome back to another lecture on DFA construction. So we'll start with the problem here. So the problem states that we have to construct a DFA that accepts a language that has the strings. So the condition that is given here is that the number of A's in the string should be greater than equal to 1 and the number of B's in the string should be exactly equal to 2. So that's what is written here. The string should have at least one A and exactly 2 B's. Now, what are the strings that would be present in the languages? You can have A followed by 2 B's, which is again a valid string. And then you can have BAB, BBA. So, AA followed by 2 B's, B followed by 2 A's and B, BBAA, and so on. We can have any number of strings. So, in this, if we analyze the problem, so here we can see that there are two things here. One is the string that starts with A and the other one is that the ones that starts with B. So first, as usual, so draw the skeleton for the minimum string. So I'll start with Q0. So Q0 on accepting A, it goes to the state Q1, and then on seeing a B or accepting a B, it goes to the state Q2, and then on accepting another B, we go to the state Q3. So, since ABB should be accepted, so this becomes the final state. Now, the next condition is that I should also have strings that has BAB. Now, since we know that this is not a valid DFA, as we know that in a DFA, every state should have one transition per input symbol. Okay, so in this case, you can see that the input symbols that we take is a A and a B. So the alphabets that is accepted here is A and B. Now what we can do is, if suppose I am here at Q0 and I see a B followed by ABB. Okay, so this is one condition, and the other one is, so in this case, if you see here you can see that we have more than 2 B's. So this is not a valid string. So similarly, if I have any occurrence of B's, so if I have 2 occurrence of B's followed by ABB, that should also not be accepted. So having a loop here is being rooted out. So I cannot have a loop here. So that condition is not satisfied here. So what other possibility is, we can try taking a transition to the next state. So I can have Q4. Okay. So this makes a transition from Q0 on accepting B, I go to the state Q4. From Q4 on accepting A, right? So on accepting A, I have two choices. So you can see here I have ABA. So one thing I can do is, instead of having this transition, I can also have a transition something like this. So I can have a transition to Q2. So on seeing a A, Q4 on seeing a A, we go to Q2, and then on seeing a B, we reach the final state. Now the next thing is, now you can also see that I also have one more condition where BBA should be satisfied. So I start with Q0, on accepting a B, we come to Q4, on accepting an A, so on accepting another B, so the next condition that we have is, it should satisfy the condition BBA. Now if you see here, Q4 has made a transition on accepting an A. So we have to make a transition on accepting a B. So on accepting a B, it goes to the state Q5, and then on accepting a, it should go to the final state. So on accepting a, it goes to the final state. Okay. Now, this is not a DFA still. So, we will analyze from Q0. Q0 has already made a transition on accepting the input symbol A and B. Q1 has made a transition on accepting B, but we have not made a transition on accepting A. So, when do we reach Q1? After seeing a, we reach Q1. Now, what happens if I see a again and a B? So, you can see that this is a valid string. So that's here AABB should be accepted. So similarly, if I have 3 A's followed by 2 B's should also be accepted. 4 A's followed by 2 B's should also be accepted. So one possibility is I can have a loop to A here. So this will satisfy all the conditions here. Now the next case is now coming to Q2. Q2 is already made a transition on B. Now the transition that is left out is on seeing an A. So when do we reach Q2? Q2 we basically reach after seeing a A and a B. From Q0 on accepting a A to Q1. From Q1 on accepting a B to Q2. So this is the basic thing. Now what happens if I see another A here and B? So again, if you see this condition, so here also we have two A's followed, you have two A's and then B. Now similarly, if I have any number of A's here, so in this case if I have A, B followed by two A's and B, it should be accepted. A, B followed by three A's and B, this should also be accepted. So in this case, so again I can have a loop here. Okay, so all the conditions would be satisfied here. Now coming to Q4. Q4 is already made a transition for A and B. So this is done. Now what happens if in Q5 is made a transition on A. Now what happens when we see a B? So basically we reach Q5 after seeing a B and a B here. So B, B. So what happens if I encounter the third B? So if I encounter the third B, this string should not be accepted because this is not satisfying the condition that is there in the language. So what do I do is, so whenever whenever Q5 sees a B, so I should ensure that this enters the trap state which is given as Q5. Okay. Now beyond this, any A's and B's that is seen, you can write it as a loop to the trap state. Now coming to Q3. So Q3 here, you can see that. So what happens if I see a A here? So when do I reach Q3? So Q3 is reached basically on seeing a B and a B. So I have A, B, B. Now being at this point, what happens if I see a A here? So you can see that this is a valid string because it has a condition that it has exactly two B's and two A's. Now what happens if I have A, B, B, A and a A again? So 3 A's and 2 B's are allowed. So any number of A's that I have here, it should accept. So in that case, I can have a loop here. So a loop to A. Now, what happens at this point if I see a B? So let me come here. So starting from Q3. So when do I reach Q3? After seeing a B and a B, we reach Q3. Now what happens if I see a B again? So you can see that this condition is not true because it must have exactly two B's. So at this point, whenever we see a B, so what we do is this will lead the transition to the trap state. Okay. So this will enter into the trap state because these strings should not be accepted. So this completes. Now this is the complete DFA for this problem. And now let's see the next problem. So the next set of problems is to construct a DFA to accept strings of A's and B's having a substring. The substring that is given is A, B. Now what are the conditions or what strings will be accepted by the languages? So the minimum string is A, B should be accepted. Then any number of A's followed by A, B should be accepted. So this condition I can have 3 A's followed by A, B. This should also be accepted. So again A, B, A should also be accepted because this has got the string A, B. And then I have this string A, B. So here you can see that I have the substring A, B. So the substring can either be in between two symbols or it can be anywhere in the string. It can be at the beginning or the end. So to solve this problem, so start constructing the skeleton for the minimum string. So I'll start with Q0. So Q0, on accepting A, we go to Q1, and then on accepting A, we go to Q2, and then on seeing a B, we go to the state Q3. So Q3 becomes the final state because this is the minimum string that it has to be accepted. Now let's start with the beginning. So starting with Q0. So you can see that Q0 is made a transition on seeing a A, but we should see what happens when it sees a B. Now the condition would be that initially, before I can start, if I see a B followed by A, this string is a valid one. It should be accepted. Similarly, 2 B's followed by A, this should also be accepted. And so on, any number of B's followed by A, it should be accepted. So what I can do is, I can have a loop here. So this satisfies all the condition here. B followed by A, and then any number of B's followed by A, is satisfied. Now I'll come to Q1. Now what happens if I see a B here? So because Q1 is already made a transition on seeing a A, so the leftover transition is on seeing a B. So what we do here is, so when do we reach Q1? On seeing a A, I reach Q1. Now what happens if I see a B? Okay, so if I see a B, I should ensure that this string is ending with AAB. Okay, so, or it should have the substring AAB. Now what happens if I have a loop here? Now if I have a loop something like this, if I loop this, now you can see that this condition AB is satisfied. So here in this particular string, you can see that I am not seeing the substring AAB. This is not present. So this is not a valid string. So I cannot have a loop here. So that condition is rooted out. Okay, so that condition is rooted out here. So we cannot have a loop here. So the loop cannot be there. So what else is the possibility? So what happens if I have a transition from Q1 on accepting a B to Q2? So in that case, you can see that A, B will be accepted. Again, which is not a part of the string. So the other possibility that is left out is, I can have a transition back to Q0 on seeing a B. Now we'll see the condition here. Q0, on seeing a A, we reach Q1. Q1, on seeing a B, we reach Q0. Q0, on seeing a A, we reach Q1. And then on seeing another A to Q2, and on seeing a B to Q3. So the string that it satisfies is A, B, B. Similarly, A followed by 2 B's, B, or any number of B's followed by B. So all these conditions are valid strings which will be satisfied with this transition. So for Q1, I've seen on accepting input symbol A and B. Now I'll come to Q2. So Q2 already there is a transition on seeing a B. What happens if I see a at this point? Now you can see that when do I reach Q2? After seeing a and a, I reach Q2. So from Q0 on seeing a, Q1. From Q1 on seeing a to Q2. So what happens if I see a third A here and then a B here? Okay. So a third A and a B. So this should be accepted because this has got the substring AAB. Now similarly, so what happens if I see 4 A's and a B? So this should also be accepted. So any number of A's followed by AAB should be accepted. So what's the possibility here? I can have a loop here, so which accepts A. So this condition is satisfied here. So you can see A followed by A and then any number of A's and B. So that satisfies the condition that's given here. So this string is accepted. Now coming to Q3. Now Q3 should make a transition on seeing an A as well as on seeing an B. Now what happens if I see a A and a B here? So when do I reach Q3? On seeing AAB, I reach Q3. Now what happens if I see a A here? Right? So this should be a valid string because you have AAB here. Now what happens if I see 2 A's? This should also be a valid string. So in case of A, what happens if I see a B? So AAB should be valid. So followed by any number of B's, this should be a valid string. So what I can do is, I can have a loop for A, B. So this completes the problem for accepting the substring ABB. So similarly, there can be any question that is asked where you will be given a substring and asked to draw an DFA. So the next problem that we have is to construct a DFA to accept the strings that end with 0, 1, 1. Okay, so to begin this again, So we'll write down the language. So here we can see that the alphabets that is accepted is 0, 1. And the other thing is the string in the language is all the string that ends with 0, 1, 1. So I can have 0, 1, 1 followed by any number of zeros followed by 1, 1. So this should be valid. 1 followed by 0, 1, 1 should be valid. Then if I have 0, 1, 0, 1, 1 should be valid. 1, 0, 0, 1, 1 should be valid. And so on. I can have any string that is ending with 0, 1, 1. Okay, so to construct the DFA, we'll start with the skeleton. So we'll construct the DFA for the skeleton. So where we start with Q0. On seeing a 0, we go to Q1. On seeing a 1, we go to Q2. On seeing another 1, you go to Q3. Okay. Now see the condition. So the condition is that it should accept all the string that ends with 0, 1, 1. So here starting from Q0, you can see that we have already made a transition on seeing a 0. So we have to make a transition on seeing a 1. So 1 followed by 0, 1, 1 should be accepted. Any number of 1s followed by 0, 1, 1 should be accepted. So I can have a loop here. And then coming to Q1. So when I reach Q1, you can see that after seeing a 0, I reach Q1. Now Q1, there is already a transition on seeing a 1. What happens when I have a transition for 0 or when Q1 accepts 0? So when I have a 0, I should ensure that this ends with 1, 1 here. So here it should satisfy the condition. So any number of zeros followed by 1, 1 is a valid string here. So similarly, if I have 3 zeros followed by 1, 1 should also be a valid. So one possibility is I can have a loop here. So this satisfies the condition 0, any number of zeros followed by 1, 1. So all these conditions are satisfied with this transition. Now coming to Q2. Q2 has already made a transition on seeing a 1. On seeing a 1. So we will see what is the transition on seeing a 0. So when we reach Q2, on seeing a 0 and a 1, we reach Q2. On seeing a 0, 1, we come to this point Q2. What happens if I see a 0 here? So if I see a 0 here, I should ensure that my string is ending with 1, 1. So this point should be taken care of. So what is the possibility that I can do here? I cannot have a loop to 0 here. So in that case 0, 1, 0, 1 would be accepted, which is not a valid string. So other possibility is I can have a transition back to Q1. So in this case, if you see, it is 0, 1, 0, 1, 1. So this condition gets accepted. So 0 followed by any number, 0, 1 followed by any number of zeros, 1, 1 would be accepted in this case. So Q2, we have a transition on accepting a 0 as well as on accepting a 1. Now let me come to Q3. So Q3, what happens on seeing a 0? So let's see for this condition. So when do I reach Q3? On seeing a 0, 1, 1, we reach this point Q3. Now what happens if I see a 0? So when I see a 0, I should ensure that there is a 1, 1 so that the string is gets ended up with 0, 1, 1. So what's the possibility here? I cannot have a loop here. So what I can do is on seeing a 0, I can make a transition to Q1. So this will satisfy the condition. Q0 on seeing a 0, I come to Q1. Q1 on seeing a 1, I come to Q2. Q2 on seeing a 1, Q3. Q3 on seeing a 0, we go to Q1. And then seeing another one, Q2. And seeing another one, Q3. So this condition gets satisfied here. So any such strings will get satisfied here. Now what happens if I see a 1 at this point? So again, so I reach Q3 after seeing 1, 1. Now what happens if I see a 1 here? So if I see a 1 here, I should ensure that there is 0, 1, 1 here. Because the string should end with 0, 1, 1. So what do I do is, so only possibility is, So from here, I can have a transition to Q0. This is on seeing a 1. So you can see that this condition would be satisfied. Q0 on seeing a 0 to Q1, Q1 on seeing a 1 to Q2, Q2 on seeing an 1, we go to Q3. On seeing another 1, it's back to Q0, and then we have 0, 1, 1. So all the strings that is ending with 0, 1, 1 is satisfied here. So this is most frequently asked problem. So coming to the next problem. So the next problem is to construct a DFA to accept strings of A's and B's starting with the string AB. So all the string that is starting with AB. So we can have AB, then we can have AB followed by A, AB followed by any number of A's, and then AB followed by B, and then AB followed by any number of B's, AB followed by AB, AB followed by BA, and so on. So any strings can be accepted. So the symbols that it accepts is A, B. So starting with the skeleton, so Q0 on accepting a A to Q1 on accepting a B to Q2. So this is the skeleton. Now let me start with Q0. Okay, so what happens if Q0 sees a B? So if Q0 sees a B, you can see that there is a condition that the string should start with AB. So it cannot start with B. So what I can do is, I can introduce one more state and call this as a trap state. So on seeing a B, if the first symbol that we encounter is a B, it enters the trap state. Onwards, any A's and B's that you see, it will get trapped to this state. Now coming to Q1. So when do I reach Q1? After seeing a A, I reach Q1. Now what happens if I see a A again? Because there is a transition already to B, the leftover is A. So again, this should also not be accepted because it's very clear that the string should start with AB. So whenever you encounter A as the second, after A, if we see another A, then I should ensure that it enters the trap state. Now coming to Q3. So in case of Q3, when do I reach Q3? After seeing a AB, I reach Q3. What happens if I see a A? So this should be accepted. Any number of A's here, it should be accepted. So I can have a A here. Similarly, AB followed by any number of B's should be accepted. So there are three problems that I covered. One is to find out the substring. One string starting with a pattern and a string ending with a pattern. So these are the three frequently asked questions. Okay. So coming to the next set of DFA problems, we have the divisible by k problems. So in case of divisible by k problems, so let's see this problem. So we have to construct a DFA to accept strings of zeros and ones where the value of each string is represented by a binary number. So the binary number is 0, 1. Okay, so only strings representing 0 mod 5 should be accepted, which means that all the strings that is divisible by 5 or are multiples of 5, that should be accepted. So something like this. So you can have the language to accept 0, 5, then you have 10, 15 and so on. All the multiples of 5 to be accepted. So here, so one thing when we have this problem, so we have to remember with the transitions here. So in this case, we have a small formula to remember. So here, you know that this symbol delta here, this is for the transition. Qi represents the current state. So this represents the current state. And then we have 1. This represents the input symbol that is accepted. Right? And then we have Qj. This gives the next state. Next state. Now to compute the next state, we have a formula here. And the formula is given as J equal to R indicates the radix. So in case of binary, the radix is equal to 2. In case of decimal, the radix is equal to 10. And then I here, so this determines the possible remainders. So we have the possible remainders. And then D here, this determines the digits that we are going to use or the symbols. And the K here is the divisor. So divisor here. So coming to this, so the radix here, because we are making use of a binary number, the radix is equal to 2, and the symbols that I am going to use is 0, 1 because binary number is mentioned. And the divisor, you know that it is mod 5, so the divisor that I am taking is 5. Now we can see what are the possible reminders. So to find out the possible reminders, so it goes like this. So initially, I'll start with 0 mod 5. So we know that 0 mod 5 is 0. Then we have 1 mod 5. So this is equal to 1. 2 mod 5. So this is equal to 2. Then we have 3 mod 5. So the remainder is 3. 4 mod 5. Remainder is 4. 5 mod 5. Remainder is 0. 6 mod 5. Remainder is 1. We have 7 mod 5. Remainder is 2. 8 mod 5. Remainder is 3. 9 mod 5. Remainder is 4. And then we have 10 mod 5. Remainder is 0. Now you can see that. So the basic reminders that is generated is 0, 1, 2, 3, 4. So whenever we see 5 mod 5, it is 0. Again 6 mod 5, again you can see the same pattern is repeated and so on. So the possible reminders are 0, 1, 2, 3, 4. And why is it important to find out this is, this actually determines the states that is present in the DFA problem. So if we have 5, the divisor as 5, we'll have 5 states. If it is 3, we have 3 states. If it is 4, we have 4 states and so on. So in this case, we'll be having 5 states. Now to compute the transition, so we'll start initially for, so we'll start with for I equal to 0. So which is my first reminder. For I equal to 0, we'll see the condition. So what we do is, we just compute what is j here. So to compute this, I'll be making use of the radix. So generally, if I tell Q0, so this indicates 0, it is the state Q0. 1, it is Q1. So 2 is Q2. 3, I'll be representing it as Q3 and 4 as Q4. So this gives the number of states that I'm using. So R is, for the transition, R is the radix into I. I is, I'm initially starting with the remainder 0. So I is 0 plus and D. D is the digit. So every state will make 2 transitions, one on seeing a 0 and one on seeing a 1 because I have 2 digits here. So this is on seeing a 0 mod 5. So this will give me my first transition. The second transition will be 2 into 0 plus on accepting a 1 mod 5. So this is my second state. So what was this equal to? This equal to the same thing as writing delta of, since I am starting with I equal to 0, this gives the first state which is Q0. So my start state is Q0, comma, and then the input symbol that we are accepting is 0. This is equal to. So the current state is 0. On accepting a 0, what do I do is I find out what is the value here. So this is same thing as 0 mod 5. So 0 mod 5 is 0. 0 and since it is in the state Q0. Okay. Now coming to the next one. It is 2 into, this is 0 plus 1 is 1. 1 mod 5 is 1. So in this case, I'll write the transition delta Q0. So this is nothing but the state Q0, comma, on seeing the input symbol 1, okay. So this is 1 mod 5 is 1. So 1 is nothing but Q1. Okay, so for this is for the first one. Similarly, for I equal to 1. So for I equal to 1, that is the second one, we have 2 star 1 plus 0. From the state Q1 on seeing a 0 mod 5, and then the next one that we have is 2 star 2 into 1 plus 1 mod 5. Okay, so in this case, I'll write the transition as delta. So we have Q1 on seeing a 0. Q1 on seeing a 0. This is same as 2 mod 5. So 2 mod 5 is 2, which is Q2. And then here we have delta Q1 on accepting a 1. So in this case, it is 3 mod 5. So 3 mod 5 is Q3. Okay. Similarly, we'll compute for the others. So for I equal to 2. So for I equal to 2, I can write the condition as 2 into 2 plus 0 mod 5. And for the next symbol, it is 2 into 2 plus 1 mod 5. So the transition here is delta. Now because I am in Q2, so this gives the current state as Q2. On accepting a 0, I compute the next state, which is 4 mod 5. So 4 mod 5 is 4. So I write the state as Q4. So in this case, it is 5 mod 5. So here I can write it as delta Q2, comma 1. This is equal to 5 mod 5 is 0. So it is Q0. So for the next condition, for I equal to 3. So for I equal to 3. So we can write the same condition. 2 into 3 plus 0 mod 5. This is on accepting 0. And 2 into 3 plus 1 mod 5. So the transition would be delta. So the state is Q3. Current state is Q3. And this would be 6 mod 5. 6 mod 5. So on accepting a 0. So we have 6 mod 5. 6 mod 5 is 1. So I can write this as Q1. And the next one is delta Q3 on seeing a 1. Okay. So this is 7 mod 5. So 7 mod 5 is 2. So I can write the state as Q2. Now coming to the last one for I equal to 4. Okay. So in this case you can see that it's the same thing. So it is 2 into 4 plus 0 mod 5. And the next thing that we'll have is 2 into 4 plus 1 mod 5. So in this case, we have delta. So we have Q4 as the state. Q4, comma, on seeing the input symbol 0. So we will compute the next state. So it is 8 mod 5. So 8 mod 5 is Q3. 8 mod 5 is Q3. And the next one, you can see that we have delta Q4 on seeing a 1. So we have 9 mod 5. So 9 mod 5 is 4. So we have the state as Q4. Okay. So only thing is, every reminder here actually indicates a state. So in this case, we have 5 reminders. So we have 5 states here. So this is how the transition is computed. And to draw the DFA, okay, to draw the DFA, so let's begin from the state Q0. So we know that there are 5 states. So I can write this as Q0, Q1, Q2, Q3 and Q4. Okay. So I'll start with the start state, which is Q0. Now starting with Q0, you can see Q0 on accepting a 0, it's in the same state, which is Q0. So on accepting a 0, it's in the same state, which is Q0. Q0 on accepting a 1, it makes a transition to Q1. Q0 on accepting a 1 makes a transition to Q1. Now my current state is Q1. On seeing a 0, it makes a transition to Q2. On seeing a 0 makes a transition to Q2. Q1 on accepting a 1 makes a transition to Q3. So on accepting a 1 makes a transition to Q3. Now coming to Q2, Q2 on seeing a 0 makes a transition to Q4. So Q2 on accepting a 0 makes a transition to Q4. Q2 on accepting a 1 makes a transition to Q0. Q2 on accepting a 1 makes a transition to Q0. Q3 on accepting a 0 makes a transition to Q1. Q3 on accepting a 0 makes a transition to Q1. Okay. And then Q3 on accepting a 1 makes a transition to Q2. So Q3 on accepting a 1 makes a transition to Q2. And then we have Q4 on accepting a 0 makes a transition to Q3. Q4 on accepting a 0 makes a transition to Q3. And Q4 on accepting a 1, it remains in the same state, which is Q4. So this is the next problem that we have solved. Similarly, we can also solve for the other thing, but here one thing to remember is which would be the final state, because it tells that it should accept, the language should accept, or the DFA should accept all the string that is a multiple of 5 or it is divided by 5. So in that case, you can see that the Q0 itself will become the final state. Why so? Because 0 mod 5 will give me a 0. If I write 5 mod 5, so this will also give a 0. If I have 10 mod 5, this will give me a 0. 15 mod 5, this will also produce a remainder of 0. So in this case, so I'll be making Q0 as the final state. So we can have similar problems on the same method. So coming to the next problem.